Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to impart techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Testing in Agile, and this is the 27th session in software testing series. Our guest speaker today is Mr. Ganesh Sai, founder of Train. Mr. Ganesh is BTech from IIT Delhi and EGMP from IIM Lucknow. He has been the founder, co-founder and founder team member of few startup companies and initiatives in the field of IT, marketing and academics. He worked for Adobe since 1999 for around 12 years. He has led and set up many of the key testing teams from scratch for various Adobe products like Acrobat, Adobe Reader, AAR, CS, tools, etc., spanning desktops, handhelds, hosted and enterprise area. He worked as head of quality engineering with Aristocrat Technologies. He has got 16 ideas approved for patents. Mr. Ganesh is the founder of Test to be Best and Dolphin community of those interested in software testing and innovation respectively. He is currently setting up Train. So without further delay, I introduce you all to our guest speaker. Over to you, Mr. Ganesh.
Thanks, Moini, for the kind introduction. All right, welcome all to this session on testing in Agile. So I'll skip this part about the introduction, which Moini has already covered. The objectives of this webinar are to understand. So first we'll get a quick overview of the various popular software development models, their pros and cons, and the evolution of Agile. And then we'll jump into to look at what is Agile Manifesto, principles and Scrum, and what is the positioning of our testing and Agile model. So we'll start to look at that. And then we'll look into the Agile team, that is Agile versus traditional, and specifically how does it impact the testing, and what is the concept of Team 1 approach. And then we'll have a look at the Agile testing metrics, which plays a key role in Agile teams as far as testing is concerned. And then how did the concept like TDD and BDD get evolved into the Agile testing domain. And then as most of you who are already into Agile might know that automation plays a key role into the Agile software development model. So we'll look at the distinction between automation tool and automation frameworks, and I'll walk you through with a very quick overview of one of the popular automation frameworks called Staff. And then finally we look at the role of tester and the test manager, how that role has evolved with respect to the traditional models in the Agile model. And then a short introduction to a course on testing in Agile. Okay, so excuse me. So let's jump into looking into the traditional models which have been there. So to start with, the earliest popular model was the waterfall model, and we all knew that the stages in this were that we gathered the requirement and then came up with a design, we implemented the design, we did the verification, and the testing phase was over here at the verification stage, and then the maintenance. And this was a sequential model. There was a linear sequencing of the constructive activities happening at different stages, and this was performed for the entire system. That is, once you have crossed one stage, then there was no going back from it. That is, it was like a falling water in a waterfall, and the water does not flow back in a waterfall. Similarly, once you have crossed the design stage and came to the verification, now you are not going back to the design stage again. So even if you find the major issues, so that was the way this model worked. And of course, you could see that the testing was done at the end of this cycle. So So this was what waterfall model was. Then came the V model, in which the part along with the requirement and design things that were being done, in parallel the testing activity started. So that is, while the requirements are getting done, the acceptance tests are getting written down. When the functional design is getting done, the system tests are getting written. When the technical design is getting done, the integration test cases are getting written down. And when the component design is getting done, the component tests are getting written down. So from the waterfall model, the shift to the V model, brought in the start of the testing right from the requirement stage, the testing activity. Now this model was further, extended, and then said, okay, once the code is written, as far as the programming activity is concerned, you build the component, then you do the system integration, then you build the system and install the system. So at this stage, when the programming is getting done, we introduce unit testing. When the component is getting built, you execute the component test. Similarly, at the system integration stage, you execute the integration test, and at the build system level, you execute the system test, and at the install system, you do the acceptance testing. So it was basically, one V next to another, so it looked like a W, and that's why this is referred to as a W model. So now, not just that the testing preparation starts at the beginning of the cycle, it's the execution also that is taken into consideration. That is the test execution. So, but when all these development models were evolving, it was still felt that there is something missing. Now what is missing? The demand from the customer for better working applications is increasing day by day. That's what was felt. And this demand is fast changing as the adoption is increasing and going more and more online. Now we are talking of the days when people started to shift from desktop applications to online applications and started to use the online media for a lot of their activities. For example, for their banking transactions, or for their mails, so like that. And as this transition was happening, the speed at which the solutions needed to be rolled out was increasing, because one was that the customer was rapidly adopting to this changing technology domain and this new medium that they have got, and second is to to avail that opportunity and build businesses on top of that. The various organizations or companies were trying to reach out to that clientele, and hence the competition was hotting up. So the 18 to 24 months cycle of release were getting reduced by shorter number of months, and hence there was a need to work at the roots rather than at the shoots of whatever was getting rolled out. So if we talk about the software, we needed to backtrack that not just at the system or the feature delivery level, but where the feature is getting developed right there, we have to start monitoring the quality of the software that is getting rolled out in the market. And the traditional models were posing challenges to delivering this kind of environment, and hence something new was needed. So what is this new thing that was needed? So something which could adopt the development model to this changing requirement, and make the teams more dynamic so that they can deliver in tune with the rapid changes that were coming in the marketplaces. So at that point of time came the Agile model. Now what did this Agile model do? The term Agile was introduced by a group of people in the Agile Manifesto in 2001. So a group of people got together in 2001, and given the situation, they came up with a manifesto. And what did this manifesto say? So which is listed at this link, agilemanifesto.org, and subsequent to this they came up with 12 principles. So if you look at, I'll just show you this manifesto. What did it say? So it said that we are uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to value individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. That is, while there is a value on the items on the right, that is all these items, process tools, comprehensive documentation, contract negotiation, and following a plan, we value the items on the left more, that is these items, that is individuals and interactions are much more important, working software is much more important, customer collaboration is much more important, responding to change is much more important. So these basically became the core values of the Agiles, and what follows in terms of the principle is basically based on these core values. So what were those values, principles? So we say that we follow these principles. What principles? Our highest priority is to satisfy the customer through early and continuous delivery of valuable software, welcome changing requirements even late in the development cycle, Agile processes harness the change for customer competitive advantages. Now, with each of these, that is our highest priority is to satisfy the customer through early and continuous delivery of valuable software. So one thing is clear that the delivery of working software has to be faster. So we don't have to make the customer wait for 12-month, 18-month or 24-month cycle. So the delivery has to be faster. Second is changes, since the delivery is faster, so the changes automatically can get incorporated with these shorter cycles. And involvement with the customer is going to be a key priority. So all the people in the team would get an opportunity to interact with the team. And in the slide where I cover traditional versus Agile, I will highlight that how that shift has come into Agile. Deliver working software frequently from a couple of weeks to couple of months with a reference to the shorter time scale. I just covered this. Business people and developers must work together daily throughout the project. That is, there has to be a mechanism by which all these stakeholders are getting together and talking to each other on a daily basis. Build projects around motivated individuals, give them environment and support they need, and trust them to get the job done. That is, just leave up to the team to deliver, and do it with, maybe a very complex project management. The most efficient and effective method of conveying information to and within the development team is face-to-face conversation. So the focus is to minimize onto, formal kind of a communication in which there is too much of email communication happening, even people sitting next to each other in a cube are, sending mails. And the encouragement is to have lot of face-to-face, conversations. Of course, it doesn't say that, for record purposes you don't maintain email thread. Of course, you can do that, but as far as possible, have a lot of face-to-face conversation. Working software is the primary measure of progress. That is, you may send reports to the customer that we have done this and we have done that, and there is so many bug fixes we have done, so many bug fixes found, bugs found, and so on. But at the end of the day, what is going to, really the customer is, a working software demo and also a copy of that given to the customer to, play around with. Next is Agile process promotes sustainable development. The sponsors, developers, and users should be able to maintain a constant pace indefinitely. That is, the pace at which their work is done should be such that everybody involved in the team, including the customers, are able to keep up with that pace for a continuous time for a long term. And then continuous attention to technical excellence and good design enhances agility. That is, there has to be some kind of mechanism that these things are getting taken care of. Simplicity is essential. That is art of maximizing the amount of work not to be done, not done. The best architectures, requirements, and designs emerge from self-organizing teams. So again, the teams are left to themselves to organize themselves, and no kind of hierarchical structure where the team management is carried out and the project management is carried out. Total trust and freedom is given to the team to deliver. At regular intervals, the team reflects on how to become more effective and then tunes and adjusts its behavior accordingly. Okay, so these are the basically the Agile Manifesto and the 12 principles on which the whole Agile software development model is based. And as we have seen that this model is iterative and incremental in nature, and the advantages are that it is rapid and flexible to changes, it is extremely tight control over the development activities and quality, and the whole team moves as one. And I'll cover more of this, that how the whole team moves as one, and some of these salient points in the slides to come. The disadvantage is that it leaves very little time for detailed research, but there are ways how you can incorporate that if needed. Teams are always on their toes. Again, this is manageable if you set the right kind of velocity in the iterations that you do. And there are tools which can help you to monitor this, and accordingly you can fine tune your velocity. So this is extremely good for hosted services project, that is, or something that you are something like e-commerce portals which are deployed on the cloud, and that is where the world is moving to, and hence this model is becoming very popular. It may not be very good for research kind of projects. Okay, so let's move on. So one of the methodologies that is used to implement the Agile model is called Scrum, and Scrum is one of the very popular Agile methodologies. Now all the requirements in Scrum, the requirements of the product or the service, are captured in the form of user stories, and the collection of these user stories is referred to as the product backlog. Now you basically prioritize all these user stories based on certain points that you give to them, and these are known as story points. And the prioritized list is taken, and they are put into small time intervals in which the delivery has to be done, and these small time intervals are referred to as the sprint. So they may be anything from 1 week to 4 weeks, and the number of story points that are being delivered in each sprint are kept more or less the same, so that you have a constant a story point achieved every sprint, and hence the velocity is consistent. Now you pick up the stories from the product backlog and you put them into the sprint backlog. So the sprint backlog will comprise of the prioritized story for that sprint, plus the various tasks that you need to achieve those story points. So for example, programming related or testing related or user interface design related, all those kind of things. And then basically as you progress in different sprints, you calculate that how much story points you have achieved. Now here is the thing. So for example, for a given story, the programming part was done at the end of the sprint, and hence there was no time left for testing. So will you get the story point for this? No, you will not get the story point for this. The team as a whole does not get the story point for this, and therefore the team has to work collectively so that all the tasks related to that story get completed. So it's not that the whole responsibility comes on the testing or the tester, because testing as an activity is the responsibility of the whole team. And hence if the story in totality is not completed, that is for example in this case the testing is not completed, so the team will not get the story points, and hence their velocity will slow down, and there are burn down charts that get prepared which will reflect this. So, and at the end of the sprint there is always a sprint retrospection, whereby we look at what were the actual goals that we wanted to achieve, what were the expected goals that we wanted to achieve, and what are the actual goals that we got. And then the teams looks at what are the practices that need to continue, what are the practices that need to drop, and whether their estimation is correct or not. All those kind of things they look into, and bring them into practice into the next sprint. Now the beauty of this is, since the cycle is 1 to 4 weeks, so hence they get to look at it at a very fast pace within like less than a month, right? And then they can, do a course correction very fast. And even if there are some changes in the marketplace, so they can, quickly bring those into the product backlog and, reprioritize the things and put them into sprint backlog, and in the next sprint they can start to look at it. Now, one of the conditions for moving out of the one sprint is that at the end of the sprint your product has to be off, or whatever features you have coded have to be of shipping quality. That is, they should be ready to be delivered to the customer. And in fact, in between the sprint, you do a sprint review, whereby you call the customer and give them a demo of what you have developed in that sprint. And if needed, give a copy of that to the customer. So on successful sprint completion, the regression suite starts to grow. Now, this is one of the aspects which is very important. So as the sprint grows, as the sprint passes by, the regression bucket starts to increase, and testing starts to become a bottleneck in the early in earning the story points due to above, if it is done manually due to fixed number of test engineers. So in a given team, the number of test engineers will be fixed. If the regression bucket starts to grow, and if you are doing it manually, then it will become very difficult to take up more user stories, because team has to move as a whole. So they cannot take up more number of stories. So testing becomes a bottleneck. Therefore, it is very essential in the Agile that you have a test automation strategy in place. Otherwise, the Agile would not be successful team, and we'll talk more about it in the later slides. Okay, so now coming to positioning of Agile testing, that is how the whole testing activity is positioned in Agile. So if we look at the various roles, so for example, the tester and then the programmer. Now, what does basically in a traditional model a tester does? So a tester will be doing the testing activity, and he will be doing activities around quality assurance, and the programmer is one doing activities around writing the production code. Then now you might be wondering, who is a developer? So okay, so you might be wondering, why are we not calling the programmer a developer over here? Now in Agile, the concept is that everyone is a developer. Now how come that? So the underlying thought is that everybody is involved in developing the software, whether a person who's coding, who's testing, who's preparing the UI design, right, or the business analyst. So all these people are part of developing that software. So everyone is referred to as a developer in Agile, and the one who basically writes the code is referred to as the programmer. So that is a little distinct from what we traditionally refer to as a developer. So everybody is a developer in Agile, and the one who writes the code is a programmer, and one who tests is a tester. But overall, everybody is a developer, and we refer to the whole team as the software development team. So in an Agile, the Agile tester delivers more than testing. So he has to look at the business value as a driver to deliver the high quality as per the needs of the customer. Now, how does that happen, and how does the tester has to evolve himself from a traditional tester to this kind of an Agile tester is something you'll get a taste of in the coming slides. The other thing is the Agile programmer. Now, the way a programmer has to work in the Agile has also shifted, and he has to bring in practices like TDD, which is test driven development, and we'll talk about that later, to make Agile team a successful team. And he has to provide tests which are supporting the team and are technology facing tests. And what do these terms, supporting the team and technology facing, mean? Now these are the terms I picked up from Brian Merrick's Agile testing quadrants. and I'll discuss about it in the coming slides when I take up the agile testing metrics. So, the idea over here is that there is a shift in the way the testing is approached and the testing is executed in the agile model. And it's not just the responsibility of the person who has assigned the testing, that is the tester. It is a collective responsibility. And why it is a collective responsibility? Because the agile team works as one team, and everybody has to see how they can take care of each other's tasks if the need be there. Otherwise they will lose out on the story points. So in agile it is encouraged that the problems encountered are solved as a team. And what does this team mean? The team includes the business analyst or the product manager, the programmers, the testers, the program management people, the release engineering people, or anybody else involved in delivering that software, and together to decide how best to improve the product or the service. So this means in agile all are focused on testing, and this is the best part, that it's not just left to a tester and he's a gatekeeper, but it is the responsibility of each and everybody to make sure that a good testing happens and a good quality of software is rolled out at the end of the sprint. So agile testing will involve business facing or the customer facing tests, which will basically look at the desired functionality and the shape of the features that need to be delivered to the customer. And it will include other tests which critique the product, that is to figure out the missing parts in the product which may add further value. And then it will include everything like unit testing, component testing, system testing, load testing, UAT, etc. So this is broadly what the agile testing would cover in terms of the top level things that need to be done. But we will look into more specific in the slides to come. Okay. So let's now quickly look at the key distinction between the agile versus a key distinction between the agile and the traditional model. Now, in the traditional model, the flow is requirement gathering, planning, coding, and testing. But generally, the last phase is rushed and causes undue pressure and delays and high risk to the quality. And testers may or may not be involved right from the beginning, especially with regard to the customer interaction. Generally, in the traditional model, they were left out, and first the product manager or they got involved with the customer, then the development team, and they kept on working with each other and delivered the code. And when the code came, got delivered, then the testing team started to get involved and they started to code, or maybe some specification was shared, but never it happened that there was a interaction with the customer. Maybe in some cases it was happening already, but majority was that the customer interaction was not extended to the testing community. Now, and then so when the basically testing team started to test in such scenarios, it was just that the code was thrown to them, and they were expected to discover all the bugs, and this created an illusion of the control of quality by the testers, and hence perception of default role of quality gatekeepers. Now, one was that they were not involved, so they didn't have the context of where the need is coming from, what is the customer expectation, and hence there was a gap. Second was, it was thrown to the testing community, and it was taken for granted that they are the quality gatekeepers, and they have to ensure that everything is working fine. If it doesn't work well, then it is testers who have failed. Now, which was like a total disconnect, right? But the perception prevailed. So, and missing major source of quality was okay. So the major thing that everybody was missing in this whole flow was that what is at the source of the quality of the software that is getting delivered. Now, if you look at the source of any software that is getting delivered, are the lines of the code that are getting written, and we have to make sure that each and every line that gets written over there, there is enough thought process that has gone before those lines of code are written. And then when it comes to system testing and finally to the customer, there will be very little bugs, and hence the cost will go down, and the customer, on achieving this software would see, okay, his expectations have been met. Otherwise, we will be getting into a loop where there are lot many bugs, and even after fixing those bugs, when it goes to the customer is getting something which is not up to the expectation. And this is not something that I am making up. Actually, if you look back in the history of the software evolution, this has been happening actually. So the earlier product release cycles were slow, say 12 to 24 months, and by the time the product got to the release, there were new developments in the marketplace, and hence the last minute changes put undue pressures on the team, and most of the time changes are not even made due to such a fear. So I remember once I was working on handheld devices, and we were rolling out the PDF readers, and there used to be many times when we were just few days from making the product GM, and we'll come to know that some major vendor has hardware vendor has decided to launch another handheld device into the marketplace, and since the our release cycles were longer, so we would we would have to reschedule either the release date, and in a way that we don't delay it much, and then there used to be really a very short and fast-paced cycle to test the product on that new hardware, to make sure that we are able to list that hardware into the release. So those are the kind of pressures that get built up in long release cycles. So some of the other aspects are that all the requirement delivered are as per the specifications, and the development teams are not in direct touch with the customers. Now, this may or may not be true for some of the teams, but majority, the whole development team was kept away from directly interacting with the customers. And programmers have specialized skills with respect to the code areas, so they really didn't become cross-functional. So if one programmer leaves for a 1 month leave, then the whole schedule goes topsy-turvy. And then testers depended on requirement doc to the right test cases, and there was no other means for them to basically get to what exactly is the customer as a stakeholder looking for in terms of the value that he wants to drive through this software, and hence there were gaps. And then came the Agile. So in Agile, the concept was to get to ship ready state after every 1 to 4 weeks, which seems not possible, especially for big and distributed team, but actually this is now a reality. And the other aspect was work closely with the customers and business facing teams, focus on delivering value which each team member can contribute to and deliver. And testers get in action right from the start. They look for ways to contribute throughout the cycle. So when I say they look for ways to contribute throughout the cycle, it's just not testing actually. So if needed, they should be able to contribute to coding activities or business analyst activities like that. So the teams adopting Agile have to be really cross-functional. That is, since it's like that if the the development, if the person who's programming has taken longer than it would have taken to code a particular area, then that leaves very little time for the person who's testing to test it out. So whatever little time is, the programmer and the business analyst would pitch in to help out in the testing. So they have to know how to do testing, and similarly the testers have to evolve themselves to become coders. So they should know how to code, and if the build for testing is not coming out, and if needed to help out in writing some piece of code, they should be able to write that out. Or in terms of doing some analysis for business analysts, they should be able to do that. So person in a testing domain has from a traditional model has to evolve himself to be more cross-functional when he moves to Agile. And this is not, just for himself. Of course, it is going to benefit him for in the long run, but also for the team, to scale up and to deliver, good quality of the user stories, and then, have a good velocity and achieve good story points, good number of story points as they go from one sprint to the other stream. That is how they become a really good Agile team who deliver, story after story, and along the way, it becomes, that each and everybody is so much involved, working for each other, that they make a really powerful team, and which goes a long way, for delivering onto that software. And it's not just delivering the software. Even as a team, you enjoy working on the software, and it's much more fun. And like you carry that fun in your personal life, and your personal life quality improves. So overall, you get into a very positive cycle. Okay, so teams adopting Agile sometimes do not feel the change from traditional. Now that might be something, some of you who might have experienced that, we move to Agile, but there is no difference. Well, in that case, either it is not yet Agile, or the team was already Agile rather than traditional. But in either case, it makes, sense to get an Agile coach to do an assessment and see, where you are. So at times what happens is that, when people, teams move to Agile, they start to practice mini waterfall, and hence, they get all, puzzled that, like, what is this Agile? It's not helping us at all. This is all, hype that has been created, and, we have been caught by that frenzy and, adopting it. It just doesn't make any sense. So, so in that scenario, it's best to get an Agile coach to, get a, to get a guidance of where you are. Okay, so I'll skip this. So quickly, this is on the left side, requirement design, implementation, verification, maintenance. That's the waterfall model we started with, and along the timeline it proceeded like that. And in terms of Agile, we have the different iterations. So in iteration 0, we do the planning, and then we add in iteration 1 feature A, B, in iteration 2 another C, and then D, and then E, F, like that. In successive iteration, the features start to build up. And you can clearly see the regression bucket will go on increasing as the iteration proceed. And hence, it is very essential that if you have to, maintain a good velocity of earning the user stories, you cannot do away with test automation. If you are not adopting test automation in a big way, if you are in Agile or planning to Agile, then you are setting up yourself for a failure. And I'll talk about, when I come to the role of tester, that how it will impact a tester's career in the long run in Agile team. Okay, so generally the time for testing gets squeezed in, especially in the traditional model, large chunks of code get delivered towards the release date. Now in Agile, small portions of the code get done and tested in small periods of iteration. So this is with reference to the previous slide. That is, in traditional, large chunks of code will get delivered, and more of them get delivered at around the release dates. So that puts a lot of pressure. Now in Agile, a small portion of code gets done and tested in small periods of iteration. So some of the key points are that stories are not counted as done till the testing is completed. Teams are highly adaptable to changes. Team members highly adaptable to changing needs of the team. TDD is actively followed, and I'll talk about it in one of the slides. Tests are created in collaborative manner with business-facing persons based on user stories and examples, distinct from the requirement specification approach in the traditional, and I'll cover that in the coming up slides. Testers may pair up with developers for automating tests. Now, since testing is a collective activity, so hence, the programmers, so I've written developers over here, actually it should be programmers. So programmers have to, pair up with the testers in order to make sure that the testing time get reduced, and whatever test harnesses need to be placed, effective test harnesses or enablement in the code has to be done to ensure that the automation can run smoothly. That is taken care of. Regression test suites are automated when tests showing the minimum functionality as complete and working, then the team can consider story as finished. So this is another critical point, that the test have to pass, of course, and they have to show that the functionality is complete and working. Then only the team can say that the story is finished. Now, the final call of whether the story is done or not and the story points are to be given or not is with the product manager. The product owner. So briefly about the team structure of the in Scrum. So there is a product owner who looks into the user stories in the product backlog and the sprint backlog, and then there is a Scrum master who basically ensures that the various Scrum values are driven, and then there is a development team, and these all are guided by an external agile coach who is external to the organization. All other texts like performance, usability, etc. are done early in the cycle and help in refining the design and coding. And yeah, that's another thing, that since you have to make sure that at every sprint, your product has to be of shipping quality. So you have to make sure that the non-functional testing is also taken care of, like performance, security, and usability. A retrospection is done at the end of each iteration. Various aspects are brainstormed and learning are taken up in the next iteration. Hence the evolution is fast, and so is the course correction. So you're not waiting for a long cycle to complete and then see what went wrong and how to correct, or what went well. But after a very short cycle, you are doing a retrospection and making course correction. And I've been talking about that the team works as one unit. So what is this team one approach? So all persons work as one team. It is not just testers' responsibility for the quality. The whole team has the ownership. Even at times, testing is shared by other team members apart from testers. And the focus for all is to maximize value to the customer in as little time as possible. Now, this is something which whole team takes on and hence plays a key role in the testing. Each and every person plays a key role in the testing. Once all feel done, then they move to the next level. Now, a lot of emphasis on designing code for testability, and hence easing automation is automatically built into this model. And there's a lot of collaboration in the team, and asking for help is highly encouraged. Now, once the team is working as one, then asking for help from each other is comes naturally. You don't have to really bring yourself up to it. And whatever challenges are there, the teams learns to adopt to it. However, the value to the customer and the satisfaction of the team make it all worthwhile. So there will be challenges when you start adopting Agile, but the overall satisfaction in the long run, not just for the team but also for the customer, gives gives you a lot of drive to take it forward. Okay, so let me talk about Agile testing metrics now. Right. So in terms of the Agile testing metrics, this concept was brought forth by Brian Merrick, so the underlying thought over here is that the requirement of the software drive various purposes of the software. That is, whosoever is in need of that software, and the requirements, whatever are there to drive certain purposes that the user or the customer wants to achieve. Now, how do we capture the various purposes of the various aspects of the software? Because if you look at it, on the one side is a business aspect, and on the other side is a technology aspect. Now, so if you look at a simple case of a calculator, on the one side it is the users who are going to use it for do various calculations, and other side is the technology that to do various computations like finding the square root or storing in the memory. You have to implement it using various technologies. Or let us say if you are basically implementing a 3-tier e-commerce portal, on the front end side, the users want to look at the user interface, the usability, how the checkout cart is, and all those stuffs. But at the technology level, we have to see how the infrastructure is going to be set up, how the business layer is going to be built, how the data layer is going to be built, how the load balancing will be done, what kind of machines you need to put in place, what kind of architecture you need to have for this whole business layer implementation, and those kind of things. So, and then there has to be a strong connection or a link between these business aspects and the technology aspects. And then there is more of which will be programming related, and the other would be driven more from users critiquing. So one is that, which takes into consideration and the limitations of the programming or the team which is developing it, and the other is people who are totally driven by the end user's requirement, and they are very critical about it. For example, performance or ease of use, those kind of things, and they don't care about what kind of team you are, what kind of technology you are using. They just want it. So if their checkout time from an e-commerce portal should not be more than 1 second, it should be like just on the click right there, right? So for example, if you're searching on Google, right, the user will not care how tough it is to basically index different pages and search for something and then bring it up. If it takes, let's say 10 seconds, you'll say no, I don't want this. So people want it, the moment they type it, within a second the result should come. That's the kind of the critical user's requirement is. And in a competitive world, the teams that deliver that kind of thing, capture the marketplace. So the ATM, that is the Agile Testing Matrix or quadrants, make an attempt to address this. And so this is how it looks like. Let me share this graphic with you. So on the one side you have the business facing side, and the other you have the technology facing. On the one side you have supporting the programming or the supporting the team, and on the other we have the people who critique the product. And the combination of supporting the programming and technology is referred to as quadrant 1, Q1, and here we try to capture all the examples that use interior terminology, and the focus is more on basically developing unit tests in line with what the user or customer is expecting. Since this is happening at the code level, this is all where the unit testing applies, and the concept like TDD, that is test driven approach, come into picture. Now if we move to the business facing side in combination with support the programming or the team, we try to capture all the examples that use business terminology. Let's say if it is a a banking solution, so you will try to capture terms of the banking solution like the IIR or the compound interest or the simple interest, those kind of terms. So the terminology used would be that of the business side, because that is what they understand, and then you capture in specific examples. Now in the traditional model, what you will do is basically you pick up the specification document and write the test cases. But here, if you see, the team has to get started to interact with the user and customer to get a sense of what this business facing area is, and then capture the specific examples and then tie them to the code that you are running. Now in the traditional way, you basically capture the test cases and through the specification documents, and those on the base of those specification documents the code was written. So hence there was a kind of a linkage, but there was no kind of a direct linkage. It was indirect, and we delivered on that kind of a linkage, because ultimately it is the the specifications that are getting coded. But can I run through the specifications directly, or can I capture specifications in a way that it takes all the examples into consideration, or can the examples themselves become the specifications? Now the new kind of methodology that has evolved is called the behavior driven development, whereby you capture the behavior which the business facing side is looking into in simple wiki kind of a page, and that wiki kind of page has a technology enablement which would through an intermediary layer connect to the underlying shipping code, and therefore even the users and customer can write their user stories and run the test. That way the gap between the business facing and the technology, further reduces down. So over here we are deploying anyways, TDD approach. Here we apply DDD. That makes it even more, like agile. And then there is this Q3 and Q4. So Q3 is, all about exploratory testing. That is, you look at the critical bugs reported by the customer, and then you use human intelligence to figure out what might have gone wrong. So all exploratory testing is done in Q3, and Q4 is, all about the various utility testing that we generally refer to as. That is, for example, security testing, reliability testing, performance testing, those kind of things. And this is all, done through tools. So for example, if you have to simulate, 1,000 users, so it will be hard to basically set up those 1,000 users and do it. So you have specialized tools like load runner, JMeter to do those kind of testing. Similarly, security testing and those kind of testing. So these are the the 4 quadrants of the agile testing metrics. And whenever you are basically designing your tests for any user story, you picture the agile testing metrics and see whether you have captured in your test scenarios and test cases aspects related to all these quadrants. And once you have covered everything, you would have pretty much covered everything that is needed from the aspect of totally testing that user story from all aspects. So just to dive a little bit more into test driven development. So it is basically writing tests before shipping code is written. So if you write tests as above and run them first, what will happen? Now you write a test and there is no shipping code, so then obviously the test would fail. So then what do? You write the code for it and then run the test again, and then it may pass or it may fail depending upon if you have written the code correctly or not. And you will keep on correcting the code till the time the test pass, and the test would come from what the requirement is from the user or customer feature or the story. So we have this cycle of write the test code, write the shipping code, run the test, fix the issues that you found, and then again write new test code. And you keep on repeating these steps till all your user stories are complete. This is what is referred to as TDD. Now, one of the key points about TDD is that TDD is a design approach. That is, you take this approach to design your shipping code, and it is not a test approach. Of course, once the user story is completed, then you can use the same unit tests for regression testing. But when you are writing these tests, so this is not a test approach, this is a design approach. That is a critical thing that needs to be kept in mind. So it is for the programmers and not for the testers. So it is always programmers who have to practice TDD and execute TDD, not the testers. Coming to BDD, BDD is behavior driven development, and so even with the adoption of the agile and capturing requirements using user stories and involving customers, the customer still found something missing, and that is how this BDD concept got evolved. That is, the delivered code was in line with what was discussed with the customers, but not what they were really looking for. So they accepted, yeah, like this is what we told you, right? But this is not exactly what we were looking for. So then the thought was, how do we bridge this gap? That is, we need a mechanism to capture the various kind of examples which depict the required behavior, and that will minimize the gap. That is what was thought out. So how do we do it? And this is what the behavior driven development is. So let me just demonstrate it. So there are different tools for it, so I'll have to rush through because we are running out of time. So there are different tools like Fitness, RSpec, and Cucumber, and I'll just show you with one of my tools over here with Fitness. So for example, let's have this one. So here's an example of basically, you see a table over here. So consider there is a software which is, the calculator software in which you, feed in 10 and then you say, divided by 2. The quotient will come as 5. 12.6 divided by 3. So you can keep on, adding the values like this, and then you click on run the test. And then based on basically different values, it will say the green line say pass, fail, or pass or fail. So for example, 10 divided by 2 is 5 is pass. But this it says 100 divided by 4 is 25. Whereas what I was written was the value I feeded was let me just go over here. So the value, so you can edit this test simply by clicking the edit button over here, and here I had written, for example, 24. So I can correct this as 25, and I can add so if let's say I can add, so let me say if I leave this over here as blank, and then save it, alright, and if I run the test, so now that has passed, and this is basically it is giving us an option of infinity. So if I go back and edit it, right, and say infinity, right, and save it, right, and test it again. So now all the tests are passing. Now this kind of a wiki page is available for your features to the customers as well, and they can keep on writing their test cases. Now the key thing to note over here is that over here the numerator and the denominator are getting mapped to the actual numerator and denominator. If I have a let's say calculator, sorry, okay, let me just see. So for example, I said 10/2. Now when I say these are getting stored in some variables, and this is what these these variables are actually mapping it to the the variables in the shipping code. And how it is getting mapped is basically there are test fixtures that are there, which enable it to pass it on to the actual code. So I'm not going to the detail of that. Maybe I can have separate session for a behavior driven development. But the idea is that you capture all the examples in a simple wiki page like this. Even the users and customer can do in their own domain language. They can edit it and they run it over there. And since the development team is also looking into this, so all the failing scenarios which they see, so they can correct the code in line with that, and then the customers, users, and the development team are on the same page. That is this very page actually, if you see. So let me move on a little faster. Okay. Now the other thing which I highlighted was the importance of automation in the agile testing. In the agile teams, the regression buckets would really grow very fast, and they will become a bottleneck if not automated. So we need to do a lot of automation. Now, so first we have to see the various automation tools for functional testing as well as non-functional testing. So functional testing, there are tools like, but first you have to understand the distinction between automation tool and a test automation framework. So test automation tools will be used for functional and non-functional testing, whereas automation framework would enable you to run your tools and test cases automated on the whole range of different platform configuration, browsers, third parties. So for example, you are testing an online app. Now you need to test on Internet Explorer, Firefox, Chrome, Safari, and then on different operating system, Mac, Linux, Windows, and then the various versions. This metrics will be huge, and there may be different languages also. Now how do you manage that? How do you run them in parallel? How do you set up different machines to do that? How do you trigger the the test? How do you monitor them? How do you send the email once the result is done? How do you set up the dashboard? All those kind of things are taken care by the test automation frameworks. Now typical tools are for functional testing, Selenium, Qtp, RUT, Test Complete, Water, etc. And non-functional you might heard like JMeter, Loadrunner, Purify, Valgrind, etc. And coming specifically to the automation frameworks, so you have to have things like test invocation, test monitoring, resource management, that is test case management, machine management, logging mechanism, reporting mechanism, and so forth. Now one of the popular automation frameworks is STARF, and STARF stands for Software Test Automation Framework. This is a peer-to-peer pluggable framework geared towards test automation. It was created in IBM in 1988 and got the funding in 1999 and was open source in 2001. And it is available free of cost under EPL license. It has 350 plus IBM teams working onto it and 275 plus external companies. Around 500K downloads have happened since 2001. and it is consistently ranked as top 50 project on SourceForge.net. So Staff is an open source automation framework designed around the idea of reusable components called services. It is intended to make it easier to create automated test cases and workloads. And Staff can help you to increase efficiency, productivity, and quality of your testing by improving your level of automation and reuse in your individual test cases as well as your overall test environment. So this is peer-to-peer, that is there is no client-server architecture. And I would have given you a demo for Staff, but since we are running out of time, so I'll skip that. Maybe some other time. So let me quickly walk over the role of testers and test manager in Agile. So a tester in an Agile team, first of all must learn Agile, and then he has to become cross-functional. That is, you have to acquire automation skills, you have to acquire coding skills and other skills to scale up to be a good Agile team member. And you have to really unlearn the waterfall model, right? And since most of the companies are adopting Agile and teams are moving to Agile, if you don't get into shape and learn it, then you will be left behind, and maybe teams may basically give you bad ratings, and hence your career will suffer. Test manager, for test manager now, the new reality is that there is no room for project management. The whole project management is done by the team themselves. So that leaves a lot of free time to the test manager. Now this may lead to an insecurity, and sometimes there may be a vested interest on making the Agile a failure, right? But that is not going to help, right? Because the worldwide it has been proven to be a good model. Now, so what is test manager left with? So he's left with the people management. He still has to do the appraisals of his team. The reporting still remains with him. So he needs to scale up to be a better mentor to the team. He has to learn more about Agile, how the working Agile is to be done, attend conferences, meetups, take up training modules, research on the case studies, and suggest to the team new ways of doing things and experimenting with the tools. So that's the new role of the test manager. Okay, I'll skip this quiz part. Okay, and yeah, so finally I want to give you a short introduction to the new course on Agile that I've launched. So it will cover introduction to Agile, introduction to Scrum, Agile testing metrics and quadrants, test positioning in Scrum, role of testers and managers in Agile, test strategy and planning in Agile, test automation in Agile, regression testing in Agile, defect and bug management in Agile, test reporting in Agile, tools used in Agile, and then challenges and support in Agile. Here is a link to this course, so you can check this out, and that's available on techgig.com. If you go to Learn It testing courses section or the courses section, just type Agile testing and you'll get it. And here are the other courses from me: Selenium test automation and software testing course. Here are my contact details. You can reach me over here. All right, so let's keep moving. So any questions? Okay, so the question is, what is product backlog? Now, as I shared with you that in Scrum, all the requirements are captured in the form of user stories. So the user story will be typically is that as a dash kind of a user, if I do something, I should get this. So as a user, when I do this, the result should be this. For example, as a user, when I log in, my customized login page should come, right? Or as a user, when I enter 10/2, the answer should be, I should get the answer as 5. So these are the different kind of user stories which are captured as requirements, and a listing of all of them is prepared by the product owner, and this is what is referred to as the product backlog. Yeah. Okay. What else? Okay. What is the role of bug fixing in Agile? Okay. So very good question. So bug fixing, so first is that as soon as the binary is available, the person who's testing it start testing it, and the bugs that are the bugs that are found are reported, and these bugs have to be fixed on the severity priority basis, and the team as a whole has to decide in their daily Scrum meetings that what bugs need to be fixed and what bugs need not be fixed, and all the critical bugs before the end of the sprint need to be fixed, and if they are not fixed, then the story is not considered to be complete, and hence the team does not get the user story points. So that's about the role of bug fixing in Agile. Okay, what is the role of tester in deciding the story point? Very good question. I'm glad you asked it, Sanjeev. In Agile, what happens is that at the beginning of the Agile, when the user stories are listed down by the product owner, the whole team sits down to generate the story point. Now this includes even the tester, and so when they sit down, so there are different techniques of giving the story points. So one of the techniques is called the poker points. So what is done is that you have cards like maybe a Fibonacci number series. So 1, 2, 3, 5, 8, like that, and then you have set of these cards, and so each one sits with them, and when the story is brought up, so everybody is asked to give points to this based on the task that they would be doing, and let us say the programmer gives 3 points, but the tester gives 8 points, because he thinks that he has to test. For a programmer it is just a minor change, but for a tester he has to test all the configurations and the combinations, everything, so it will take a long time for him. Now so the team has to discuss it and brainstorm it and reach to one single user story point. It's not that that one person can walk away with it. It's not like that. So the whole team, so if the tester says it is going to be 8, so then like if that is the highest one and the team agrees that that is what it is going to take, so that is the amount of story points that are assigned to the user story. And that's how it becomes everybody's responsibility to make sure that they are contributing into testing, so that the delivery or attaining the story points is not slowed down. Yeah, so the tester has a critical role in deciding user story points, because the testing tasks are based on the points that he is going to give when the story points are getting decided. Yeah. Okay. 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 If during testing we get a change request in the middle, how will it be handled in Agile? Okay. Now, first of all, so good question, Ranjan. So first of all, if you basically get a change request in the middle of the sprint, so you will just add it to the users to the product backlog, right? If it is very critical to implement it, then you will end the current sprint, reprioritize the story and start a new sprint. Now that is rarely done. So you will finish the current sprint as it is at the whatever you have taken on to implement, put it in the next sprint, put the task along with it and then implement it. But you never take up something in between a sprint and implement it in that sprint. So if you have to do that, you have to end that sprint then and there, break it and then start a new sprint. Yeah, so that's how you do it. Okay. What will testers do at the beginning of the sprint? Again, a very good question, Vishnu. Okay, he has left, but I'll still answer. So they start to get involved with the customers, and they see what is the business value that they are looking for. So all the business facing aspect which I shared with you in the ATM concept, that is where they get involved into. Okay. Okay. Can you share the PPT at the end of the session, please? Vijay Kumar, there will be a recorded session available, so you can have a look at that. Okay. Let me see. What are the parameters to decide the story points? It's a various tasks that you need to deliver in a given story. That will the effort that will be needed in terms of man hours, that will decide the story points that are to be given to that story. Okay. Generally, who will prepare the stories? The user stories are written. So this is from Rama Reddy. So the user stories are written by the product owner, and it's not that the team cannot share the user stories. So they can share the user stories, whatever they can think of, but the overall listing has to be maintained by the product owner. What is ideal iteration time? Hemal Raval. So Hemal, it depends upon your team and what they're comfortable with and what the user and customer is comfortable with. It can vary anything from 1 week to 4 weeks. 4 weeks is the maximum. Minimum is 1 week. So it depends upon your team and your users and customers. Agile has lesser documentation done. Is it an advantage and disadvantage? Okay, so Jagdish Bandari has asked this question. Okay, so the answer to that is okay. If the team is really agile and there is a lot of trust inbuilt and there is a lot of collaboration and interaction happening in the team members and the user and the customer, you can have very little documentation. And doing a lot of documentation, as you have seen in the traditional approaches, doesn't help much. So you have to really scale up to being agile rather than focusing on the documentation. Of course, for record purposes, certain documentation has to be done. For example, the contract that has written down, you have to do that. So those kind of things, minimal documentation, or certain crucial decisions that have been taken. For example, winding up a sprint and starting a new one in the middle of the sprint. Those kind of decisions you need to capture somewhere in minutes of the meeting, like that. Difference between product backlog and sprint backlog. Product backlog is, as I mentioned, it is a complete listing of the user stories, and sprint backlog is the user stories for that sprint plus the tasks related to those user stories. Okay, what are some certifications that a test lead can take up, certify himself as an agile tester? Okay, Jagdish, so I just shared towards the end a link to the agile testing course that we have launched along with TechGig. It comes with a TechGig certification, which is like backed up by Times of India Group. Yeah. Okay. Priyanka has a question. She says, is it mandatory that iteration cycle should be of 1 month? No, Priyanka, it's not mandatory. You can have anything from 1 month, 1 week to 4 weeks. So it depends upon your team and your users and customers. Okay, Sonali asked questions. What is the role of Scrum Master? Scrum Master, is the role which can be taken up by any a team member in the Scrum, and the role is to basically make sure that we are implementing the Scrum values very well. So he has to be really well versed with the Scrum methodology and the Agile methodology, and he's an observer in the team, and he would do the course correction and take a stand. So if everybody is not present in the daily Scrum, so he will not let the Scrum meeting start, and he will get it addressed with the concerned manager that some person is not attending the Scrum meeting. That's it. Okay, one question is why Visual Studio 2012 and MTM added to the automation testing tools? I did not get this question. Well, if we look at the ATM metrics, so in Q1 you have the unit testing that is getting addressed by these tools, and in terms of the business facing side, you have the tools like fitness and all, which get integrated with the various source code management tools. And in terms of architecture practices, again Visual Studios has modules related to architecture. So in a way, if you look back over the history of 10 years of Visual Studio, so it has evolved over the years, and it has been incorporating the latest techniques and processes that have been coming in. So and further as the concepts evolve, they will get those things into their tools. So yeah, so that's my answer to this. What is retrospection? Retrospection, Shivam, is that we do at the end of the sprint to see what went well, what did not go well, what practices to carry forward, what practices to drop, and what new practices to take up. Okay. Okay. Okay, I think rest of the questions, because running over time, so rest of the questions I'll answer offline on the webinar recording page. So leave your questions over there, and I'll answer your questions over here. Thank you very much once again for attending this, and I appreciate you taking out your time and attending this webinar. Thank you so much. Over to you, Moini.
Thank you so much for the session, Mr. Ganesh. It was a great one. I would also like to thank all our participants for their support. I would request you all to send your remaining questions to the webinar page. Mr. Ganesh will answer them there. Also, the recording of this session would be available on the webinar page on techgig.com by evening. Thank you all. Have a great day.